This meeting is being recorded.
Okay, I'm gonna leave now. Bye.
Okay, sharp. Good afternoon, everyone. Welcome to the Geomorphology class offered by e-Tutors. My name is Bokantiano, and I'll be doing Geomorphology with you for today. The session won't be long, but I can assure you it will be informative. So, as I said, we're going to do geomorphology. There are three things that we're going to focus on, mainly the drainage systems in South Africa. The second one will be the Flavian processes, and the third one will be the catchment and the river management. The most important one being the Flavian processes. So, geomorphology is defined as the study of landforms, their processes, their formation, and the sediment at the surface of the earth. Although the process doesn't only occur on Earth, but then our main focus is on Earth because we are on Earth, but then it also occurs on other planets like Mars. Yeah, the easiest example I can think of is Mars. Okay. So as I said, we're going to focus on three things: the drainage systems in South Africa, the Flavian processes, the most important one, and the catchment and the river management. So let's get started with the drainage systems in South Africa. Before we start, the most important thing with this topic or chapter is the definitions. There are so many definitions that you want to come across, and some of the definitions are similar to each other. So you need to pay special attention to the definitions. So starting with the drainage systems in South Africa, we start by defining the drainage basin, which is the total area of land surface drained by a stream network. So a drainage system is a drainage system, the system as the word implies, system. So the system has inputs, it has flows, it has storage, and it has output. So our main input of the drainage system is precipitation, or we can say rain. And then we have flow. This is where you have the streams where your water flows. You can see with the stem flow and the flow. And then we have the storage. The storage, we have infiltration, where the water percolates through the rock and the soil to be stored as groundwater. And then we have another form of storage. We can have dams, we can have rivers, and then we have the output. The output is the channels when they lead to the sea. So in simple words, the process starts at the mountains where a river starts. The river originates in the mountains, and then it runs through different areas until it reaches the sea. So this picture aims to tell us which process occur during the drainage system and the drainage basin process. And then we have these terms: the drainage basin, the source, the tributary, the confluence, the watershed, the mouth, the gradient or the slope, infiltration. You need to know how to define these terms and how to apply them on this picture. The source will be where we start. The tributaries will be the river channels, and then the mouth will be where we end, which is the sea in most cases. So moving along, we have different drainage patterns. We have different drainage patterns, and for each drainage pattern, you have to know the requirements for formation for dendritic pattern to form, what needs to happen, for parallel pattern to form, what needs to happen, and for trellis pattern, rectangular, and so forth, what needs to happen for them to be formed. The second thing to know is the characteristics. You have to know what are the characteristics of each pattern. And the third one, you have to know the examples. And then in our case, we use the examples in South Africa because that's where we are. So I'm gonna share a screen where you see where does dendritic come from, its requirements, its characteristics, and its examples. But I have to go through the slide first, and then I'll do that in a moment. Another thing with drainage systems, you have to know the drainage density, the stream order, and the river discharge. So the drainage density is defined as the average length of the streams in the area of a drainage basin. And then we have a formula to calculate the drainage density. And it is defined as total length of streams in kilometers divided by the area of drainage basin in kilometers squared. And then here on the right, we have stream ordering, and then we have rules to apply when you name is this my stream number 1, stream 2, stream 3, stream 4, or stream 5. But then everything I'm saying here is an introduction. We're gonna see everything in the textbook when I share my screen with you. And then we have river discharge, which is the comparison between laminar flow and turbulent flow, the other one being calm and the other one being destructive. We'll also see that in the textbook. And then after drainage systems, we're gonna do flavial processes. And then the flavial processes, they're also in the textbook. So basically what we are doing, we're gonna start at the mountain and we're gonna end at the sea. And we're gonna check the processes that occur between the mountain and the sea. We're gonna check the landforms. We're gonna check the river profile, the concept of river grading, river rejuvenation and capture. And then lastly, we're gonna do superimposed and antecedent drainage patterns. And then the third one, we're gonna do catchment and river management. And for catchment and river management, we're gonna do 2 things, which is the importance of catchment and river management, and then the impact of people on catchment areas. So what we do that harms the rivers, or what we do that helps the rivers. So let me start here again. Let me share the textbook with you. Okay, let's wait for the textbook to load. Okay, the textbook has loaded. Let me go to the page for geomorphology. Okay, here it is. So geomorphology, we've already defined what geomorphology is. This is basically everything that the slide covered. So what are the characteristics of a drainage basin? We have already seen this picture. My name is to move these are the features of a drainage basin. And as I said, you need to know how to define these terms, because you're gonna use them a lot when you are moving forward with the topic. So we have a catchment area, we have a river system, we have a watershed, a tributary, a river mouth, the source, confluence, and so on. And then we have types of rivers. We have permanent rivers. Those are the rivers that flow all year, periodic, episodic, and exotic rivers. I take it that you have been exposed to these terms of different rivers. And then here's the part that I wanted us to do. Here on the slide, I did say we have different drainage patterns, namely dendritic, parallel, trellis, rectangular, and so forth. And I did say you have to know the following: the requirements needed for formation, the characteristics, and the examples that we have of each drainage pattern in South Africa. So we're going to start with the parallel drainage system. Here are the requirements, the characteristics, and the examples. So a parallel drainage system means that the streams are running parallel to each other, almost at an angle of 180, because they form a straight line parallel to each other. And then the requirements for them, we need a rock type that is uniformly resistant to erosion, because if we have a rock in this area and erosion happens at different rates, then at some areas, the rock will be more eroded and hence more deep. Whereas at other areas, the rock will be less eroded, and then the height of the rock will be a little bit higher. So the streams will end up interfering with each other's movement. So we need a rock type that is uniformly resistant to erosion. And then the characteristics, the streams flow parallel to each other, and then the tributaries enter the main stream at very small angles. The reason for the small angles is because the tributaries are parallel to each other, which means that the angle at which they meet is very, very small. It ranges from, I think, 10 to 15. And then the example we have is the Steelport River in Limpopo. So for each drainage pattern, we have the requirements, we have the characteristics, and we have the examples. And then the other thing that we need to do is the river density, the stream order, and the river discharge. So I've already given you the formula for river density. The formula is total length of streams in the basin in kilometers divided by the area of the drainage basin in kilometers squared. So the drainage density can be described as high and as low. As you can see on the figure here, the drainage density on the left is high because we have many streams entering the main stream, and the area between the two figures is the same. So this side we have the length of the streams is more long, and we have a number of streams, a lot of streams. And then on the right-hand side, we have small streams, but the area is the same. So the drainage density on the left is high, and the one on the right is low. And then the reasons why drainage density differs is because of the process of infiltration. If we have more infiltration, which means more water, it's percolated into the groundwater level. That means that the streams will have less water, and if they have less water, there'll be less dense, so we'll have a low drainage density. And if we have a more of runoff than infiltration, then we're gonna have a high density, because the drainage system is gonna have water running through it. Hence, we have a high drainage density. So the reason we have more infiltration is because maybe the rock type at this area it's soft. If the rock is soft, then it means the water will be infiltrated more. But if we have a resistant rock, a hard rock, then runoff will be promoted, and then we'll have a high drainage density. And then looking at the stream order. Stream order is assigning numbers for your streams, where we have 1 is the 1, 2, 3, 4, 5. So 1 is the main streams. We start at 1, we move to 2, 3, we go to 4, and then if we have 5, we go to 5, 6. And the picture here helps you with the height. You have contour intervals, and then you have the height. You have the trig stations here. You have your height. We can see the height here. It's 1.28 to 1.3 meters. So this means that the stream will start in a more, what can I put this? A more steep area. The slope is steep at 1, and then the slope gets gentler from 1 to 4. So at 1, we have a steep slope. Hence, we have many orders. Hence, we have many ones than other number, because at 1, it's very steep, and then we move to 2, we move to 3, and then when we get to 4, the slope is very gentle. And we can see this through the spaces between the contours, because the contours at 1, they are closely packed to each other, and the contours at 4, they are spacely sorry, there's too much space at contours at 4. So that's how stream ordering works. And then we have rules that we need to follow when we order our streams. So the rules read as follows. I won't read the rules for you, because I take it you're already exposed to them. But then there are more streams of a lower order than of a higher order. This means that we have more 1 streams than 2, than 3, and than 4. And you can see it here. There are many 1 streams. And then the lower the stream order, the steeper the gradient. At 1, the contour interval, not the contour interval, the contour spacing is closely packed to each other. So we have a steep gradient. And then when we move to 4, we have evenly spaced contours. So the slope is more gentle. And then the last process, the lower the stream order, the smaller the drainage basin. So if we have like the highest stream being 4, it means that it has the highest drainage basin. There's more water flowing in 4 than in 1, because 1 is short. You can see 1 is short, and then this means that the density of the stream is low. So you have to relate what we've done before this to what we're doing. Stream order, we relate it to the drainage density, and the drainage density we related to the drainage patterns. And then we then have river discharge. So river discharge is the difference between the laminar and the turbulent flow. I did say that the laminar flow is more of a calm flow, whereas turbulent is it's rough. So if we look into the textbook, there's a good explanation of the two of the river discharge. So a laminar flow is found where the water flows at the level that is even to the riverbed. And then the turbulent flow, it is found where the riverbed is uneven and steep. So the water moves in a turbulent manner. And then that's it for the first part of this topic. And then the second part is the Flavian processes, which is where we're gonna spend most of our time. So with flavian processes, we're gonna do 5 subtopics. We're gonna do the river profile. We're gonna do the Flavian landforms. We're gonna do the river grading. We're gonna do river rejuvenation and capture, and then we're gonna do superimposed and antecedent drainage. And most of the assessments for this topic, the questions come from the Flavian processes. So we're also gonna do a question where we check how the questions are structured. So let's start with the Flavian processes. The river profile. As I said, the river starts at the mountain. It originates at the mountain, and the velocity of the river at the mountain is very high, which means the rate of erosion is very high. So at the start, the upper course or the young stage, the process that occurs is predominantly erosion. The rock is being weathered, and then as we move to the middle course, the velocity of the river starts to decrease. The reason for this is because the river meets obstacles in the way, and then transportation of sediments occurs. And then at the lower course or the oil stage, then we have deposition. And the third stage is where our depositional environments form. And we're gonna look at some of those depositional environments. So at the start of the river is steep. So we have a V-shaped valley. And then as we move along, the river starts to open up, and then we have some deposition occurring, but the main thing that occurs there is transportation. And then at the third stage, we have alluvium deposition, where only deposition occurs because the velocity of the river has decreased. What we've said is illustrated in this picture. We have the source, we have high friction, we have roughness, and we have turbulence. So the velocity of the river is very high. And then when we get here, we have the lowest velocity, and we have the greatest deposition. So at the source, erosion occurs. At the mouth, deposition occurs. And then in between, deposition and transport occurs at different rates depending on the profile of the river. And we're gonna look at that into more detail. So we have Flavian landforms. These landforms are formed as a result of the movement of water from an area of high velocity to an area of low velocity. So we have floodplains. Floodplains are the flat depositional structures that you find on the sides of a river. So this is an illustration of the floodplain. This is the river, this is the channel. We have the levee here, we have the levee, and then we have the floodplains on the side. So this picture shows a cross section of the floodplain. If the water is below the material that is being deposited, then the river is gonna flow within the channel. But then if the level of water rises maybe to this level, then the floodplains will get broken, and then that's when we have floods. And then the second one we're going to look at is the natural levees, of which the natural levees are the ones that are enclosing the river within its channel. We have point bars, we have meanders, and then here are our floodplains. And then we have grading. We're gonna do it when we do river grading. And then here we have deltas, and we're also gonna do the deltas at a later stage. So a point bar, a definition of a point bar is where sediments accumulate when the river changes direction. When the river curves here, we have accumulation of sediments here, and then we define it as a point bar. The The third landform that we're going to look at is meanders. So the meanders, it's the curves of a bend that a river forms when it's moving. And the reason a river meanders is because maybe the river reaches an obstacle and it can't move past the obstacle. Then the river has to find a new course to move through. So we have a meander. And then we have oxbow lakes. We have braided streams. We have waterfalls. We have deltas. And then we're going to start with river grading. So because of time and the amount of information that I have to share, I can't go into details for what happens at deltas, what happens at waterfalls, what happens at whatnot. But I can share this information with you if you'd like. So after this, you can text me and ask for the material that I use, the textbook, the slides, and everything. So let's go back to our slide. We have done the river profile, the source, the mouth, the process that occur. We have looked at the Flavian Landforms, and then we need to look at river grading. So let's look at river grading in the textbook. So here's river grading. A graded river is in a state of equilibrium of neither erosion or deposition. So there's equilibrium when you start, but then the rock can be eroded as the transportation of sediments occur. So with river grading, we check between ungraded profile and graded profile. When we have an ungraded profile, we have a rock here occurring, and then this rock is causing a waterfall because of the steepness of it. And then we have lakes, there's deposition of material in this area, and then we have the mouth where we have the sea. And then as river grading occurs, then the rock is eroded and then transported as part of the sediment. Hence, we have a smooth transport channel between the source and the mouth. So we have the smooth concave profile decreasing in angle and gradient towards the river mouth. So the explanation that we give over now, why do we have a smooth concave profile? It is because river grading occurs. Because if you check here, we have our water table at this level. We have sediments here, and we have a lake here. We have sediments here. And then we have a rock, a resistant rock, which is graded. So if the rock is eroded, then over time, we're going to have a graded profile from an ungraded profile. And then we need to look at river rejuvenation. So river rejuvenation is basically when a river gains energy. So a slow moving river gains velocity. And then this can happen due to many reasons. Say we have two rivers here. They are moving at certain velocities. And then when another river invades the movement of another one, we have a river with high velocity invading a river with low velocity, then the velocity changes and then erosion occurs more because we now have a greater velocity of water movement. So we have different causes of rejuvenation, and they are given here as a list. Worldwide lowering of the sea level, the raising of the land forces in the earth crust. So monorebuaga tectonic movement of the earth crust, and then significant increase in rainfall can increase the energy of the river, thus increasing the velocity and then causing rejuvenation. And then if we have a rapidly flowing tributary that joins the main stream, then the velocity of the river will increase. And then river capture, where the increased volume of water enlarges the erosion capacity of the stream. So what this means is that if we have a small river flowing here, and then another one joins it, then we're gonna have a wider river, and then we're gonna have wider effects of erosion, and as a result, the river will be rejuvenated. So then we have landforms that are associated with rejuvenation, the nick point, the terraces, and the incised meanders. We've already looked at the meanders, but we have another category, which is the incised members. And then we have river capture and stream paris. This is, it's still part of river rejuvenation, the river capture. So this is defined when a river capture or stream paris, we can say it occurs when a powerful river cuts back at its source by headward erosion and captures the headwaters of a neighboring river. And then the processes that occur during river capture, we have abstraction, because we have two rivers on either side of the mountain, and then the other one is captured. We have abstraction, we have river capture as a process, and then we also have we do features that are associated with river capture. And then after river rejuvenation and capture, we have superimposed and antecedent drainage patterns. And I won't look at them now because of time, because I want us to do a question paper. But this is what they mean with superimposed drainage patterns. This is before removing the overlying rock, and then this is after erosion occurs. So we see the height above the sea changes, erosion occurs, and then we have the removal of the top layer of the rock. So that is what is meant by superimposed drainage patterns. And then we have antecedent drainage patterns. Monana, it's when movement because of a fault in the Earth's crust, there's movement of the rock. So the river was flowing in a even surface, and then after a certain process occurs, then we have this uplifting of the rock, and then the river cuts through the rock. That is an antecedent drainage pattern. So the difference is that with superimposed, the river is flowing in an area, and then there's the top rock layer, this brown layer, and then there's another rock at the bottom. So this top layer is eroded, and then after it is eroded, then we have the exposure of the rock that was inside the Earth's crust. And then with antecedent drainage pattern, we have a river flowing, and the slope is even, and then there's a slight movement because maybe of a fault or whatever the geological process that occurs. Then suddenly we have a rock that's raised. So then we have the river cutting through the water. And then we have the last part, which is the catchment and river management. So with the catchment and river management, we are just doing the importance of catchment and river management, and then we are doing the impacts of people on catchment areas. And we're also going to refer to a textbook for this. Here's why it is important to manage your drainage basins and your catchment areas, your rivers, your dams. The reason is because we can use water from the drainage basins for irrigation purposes. If we build dams, then we have a permanent source of water. We need to manage rivers to control floods, and then it is necessary to manage catchment areas to protect water resources and make use of water in a sustainable way. And then rivers can be used for recreation, like we know we can play golf near the rivers. And then management is necessary to decrease the amount of pollution that people induce to rivers. And then the impacts that we have, number one is pollution. We pollute the rivers, we change the nature of runoff by building dams, we remove vegetation, and this can lead to floods. in the cities, there's less infiltration because of solid pavement and tar roads. Swamps are drained. The ecology of the river is changed, and then Batua Fishang, they take pollutants to the river, and this damages the quality of the water. Meanders can be eliminated by means of channel, and then we have interbasin transfer of water. So those are the impacts that we have on rivers. I have study materials for which gives clear description of everything that we have done. And if any of you is in need of them, they can contact me. Now we have the rivers, the alluvial fen, the lakes, the deltas. So if you need those slides, because I can't go through them right now, then you need to contact me. And then I also have one of the modes of transport on when the velocity is high and when the velocity is low. And then one last thing I want us to do is to look at the type of questions that are asked. So this is a question paper that I got from the Mindset website. So it is question 1, it is an exam question. You are given a figure, study the figure and answer the question that follow. Identify the stages A, B, C. This is where the river starts, this is in the middle, and this is where it ends. So this is everything that we have done. The river source, the mouth, and then the transportation area. And then a cross-section of stages identified in question 1. We've gone through this in the textbook. Identify structure. D. You have to identify the structure. Or one of the water is moving in. There's an obstacle here. These gray parts, they are obstacles. So the water is trying to find new channels to move. So what that structure is. These are just typical questions that you can get. And we have one more. The flow was we have stream flow. One of the stream flow, the average stream flow was low, and then it is increased. So we have to name the profile of the river shown here. Is it this perennial or seasonal river? You give evidence to support your, or give evidence from the sketch to support your answer. And then the other question that can be asked, you have a question here, a meander. You have a meander, and then you have an oxbow lake. Monana, an oxbow lake is okay. You had a meander at B and C, a meander here. Then instead of following this path, you have a river running through this path. Then we call this an oxbow lake. Then you can have questions on that. And then you can have case studies, and then on catchment, you can have this one, upper course, middle course, lower course. So that's all that I wanted to share with you today. So if you need anything, the question papers, the study material, you can contact me, and then I'll share with you.